Hello, and welcome to the CAINE Forensics video series. In this video, we will look at using the FFmpeg multimedia framework to view, edit, process audio and video files. Please help me out by hitting the subscribe button so I can live instead of exist. FFmpeg is a command line utility that allows for the decoding, encoding, transcoding of audio-video files. For an everyday usage standpoint, one can convert videos shot with different cameras, iPhone, Android, DSLRs, camcorders, etc., into a standard format for your video editing software suite or for posting on social media platforms. The program Handbrake uses FFmpeg to convert DVDs into video files. NASA uses FFmpeg on the Perseverance rover on Mars for image and video compression before sending the data back to Earth. From a forensic standpoint, we can use FFmpeg to convert media files from obscure formats to ones that can be easily presented in court. For this video, we will focus on using FFmpeg for just some basic functions. FFmpeg runs on Windows, Mac OS, and Linux. It's free and can be downloaded from ffmpeg.org. In this video, I'm going to be using it preloaded with the CAINE Forensics distro. So if you are following along with CAINE, there are no downloads needed. The FFmpeg framework actually consists of a few tools. The most prominent is FFmpeg, which will allow you to edit, process, and convert audio and video files. There is also ffplay, which is a simple media player using the FFmpeg libraries. And all you need to do is just type ffplay and then the path name of the file to play. So for instance, ffplay kona.mov. And once it's playing, you can use a spacebar or the letter P to pause. You can use the left and right arrow keys to fast forward or backwards by 10-second intervals. You can use the up and down arrow keys to go forwards and backwards by 1-minute increments. If you want to go full screen, you can hit the F key. To advance to the next frame when the video is paused, you can hit the S key. And lastly, to quit out of the program, you can hit Q or the escape key. So if you want to play a video in full screen right off the bat, you can use the -FS for full screen option. So ffplay-fs kona.mov. If you want to play a video starting at a certain time, you can use the search option, the -SS, followed by a time specification. So if we do ffplay-ss152 kona.mov, this is going to jump 152 seconds into the video and then start from there. And if you want to play a video just for a specific duration, you can use the -T option. So let's say we want to do ffplay-ss 00:01:26 -T4 kona.mov. This is going to start, right? It's going to search to the starting point with the -SS option at the time point of 1 minute and 26 seconds. And then it's only going to play for 4 seconds because that's the -T option. And once those 4 seconds are over, it's going to pause the video where it last played. And if you want to loop the video, we can use the -loop option followed by a number for the number of times to replay the clip. If you put 0, that will loop it forever. So if we do ffplay-ss 00:01:27 -2 -loop 0 kona.mov, this is going to start the video at 1 minute and 27 seconds. It is going to play it for 2 seconds and then loop it forever. So for durations, FFmpeg understands just an integer if you want to put in the number of seconds, or it understands the time code of hour, minute, second. And there's also ffprobe, which can display metadata of the media file, such as the codec used, the duration of the media, the display size, the frame per second, bit rates, etc. The way to use it is just type ffprobe and then the name of the file. What we get back is some program information about the ffprobe version you are running, the C compiler used to create the executable, the libraries which are loaded into the program, etc. Then follows with information about the input media file. In this case, it tells us about the netcat.mp4 file. It gives us the 4cc code of the codec. In this case is ISOM. The encoder used was lav F58. The duration of the video is 6 minutes, 2.52 seconds. Gives us the bit rate, the number of streams contained, and in this case we have a H.264 video and then AAC for audio. We also get information about the frame rate, sampling rate, mono versus stereo, etc. If you don't need information about the ffprobe program and just want the data about the video, you can use the -hide_banner option, and the info about the program is not displayed. And here you can see that it only gives us information about the input media file. You can also tweak the output to show different formats and streams and eras, etc. This could be very useful when you have a batch process of many videos, and then you can script the FFmpeg to perform different conversions depending on the input. So let's go ahead and do ffprobe -show_format and then netcat.mp4. So here you can see all of the format information about this particular media file. And depending on your programming skills, you might want to actually specify the output in a format like CSV or XML or JSON. So do that. We can go ahead and up arrow and then just add the -print_format and then JSON in this case, or like I said, you can do CSV or XML or just plain text. And we are going to redirect this into a file called netcat.json. And once that's done, we can do cat of netcat.json to take a look at the JSON file. And once again, depending on the program that you're going to feed this into, you may want XML or CSV or JSON or whatever you like. Let's move on to the core program for the framework, which is FFmpeg. One of the most basic things one can use FFmpeg for is to convert a media file from one format to another. The syntax is basically using the -i option followed by the input file. Then you specify the path name of the output file. FFmpeg will know the format you want to convert to simply by looking at the file extension you choose for the output file name. So for example, if we do ffmpeg-i of netcat.mp4 and then output for netcat.mov. So basically, FFmpeg converted the input file from a MP4 container to a MOV container. And we can use the ffprobe commands to look at the streams and their encoding formats. Here we see that the output video is now a QuickTime container. Sometimes you may get a long video and you're only interested in a short segment. To extract just the segment you're interested in, you can use the -ss function to seek to a timecode. Then use the -t option to set the duration of data read from the input file. Time durations can be specified in numbers, which defaults to seconds, or they can be specified in the hour, minute, second dot microsecond format. One thing to note is that the -ss option needs to go before the -i specification for input file. So if we do ffmpeg-ss 1:27 to mean 1 minute and 27 seconds into the video, -t space 2 to specify that we're interested in only 2 seconds from the starting time point, and then specify the input by -i kona.mov. And then in this one, we're just going to basically copy the video stream out. So we're going to do -c copy for codec copy, And then lastly, we're going to name the output file called goodstuff.mov. So once again, we're basically just going to have the codec copied over. We're not actually re-encoding the video, so this should be very, very quick. Once it's done, we can use ffplay of goodstuff.mov to see what we have. And as you can see, it basically only gives us 2 seconds starting at time point 1 minute and 27 seconds in from the original movie. We can also use the -to option to set the ending time of the data read from the input file. So if we just go up arrow, instead of -t of 2, we can specify -to and then give it a time of 1:29. Let's go ahead and name this good stuff 2, but the output should be exactly the same, right? Because we're still starting from time point 1:27, and then we only want 2 seconds worth. So if we do ffprobe of good stuff 2, then we can see that it's the same clip. It's the same duration of 2 seconds. If you want to crop out certain unwanted portions of your video, you can use the crop video filter. You can specify the width and height of the output, and then by default, it will center the crop to the original video. You can also specify the upper left coordinates for the cropping by specifying the X and Y coordinates. So if we do FFmpeg, and then let's limit this video to only 3 seconds, just for time's sake. So we're going to do -t, and then 3, -i, kona.mov, and then we're going to use the video filter, so -filter, :v, and then double quotes, we're going to put crop equals W equals 640, :H equals 480, and double quotes. And then the output, we're going to say kona-cropped.mov. So what this is going to do is that it's going to use a video filter and then only crop out a portion of the video that is 640 by 480. And because we did not specify the X and Y coordinates, it is going to center it within the original video. So let's go ahead and do ffplay of the original video, kona.mov. We're going to put it in the background by using the ampersand. So you see that this is what it looks like. And now we're going to do ffplay of kona-cropped.mov. So now you can see that this is the cropped version. It basically is about a 640 by 480 centered crop of the original. Let's go ahead and put the movies back in foreground and quit out of those. And as alluded to earlier, you can specify the XY coordinates of where you want to do the crop. What we can do is ffmpeg -t3-i kona.mov -vf. This is a shortcut for doing the filter :v. And then once again, we're going to put double quotes crop equals 640, :480, :2000, :1000, end double quote, kona-cropped-xy.mov. So I'm basically doing some shortcuts from the previous command line. So instead of explicitly writing out the W's and the H's and so forth, you can just put the 640, :480, and it will know by placement that is the width and then the height. And then for the 2000 and 1000, that's going to be the X and Y coordinates of where you want to start the crop, meaning the upper left-hand coordinates of your cropped window. So once again, let's go ahead and do ffplay of kona.mov, put that in the background. And then we're going to do ffplay of kona-cropped.xy.mov. And as you can see from the results here, the output window is still 640 by 480, which is we specified. But then the starting point now, the upper left-hand corner, is the coordinates of 2000 for X and then 1000 for Y. Let's look at another example video. I'm going to do ffplay of traffic.mov. So here you notice that the traffic camera, the dash cam, is slightly canted. So everything looks a little off. And so this is fairly common in some of the videos that you might get. And you want to view it where the horizon is parallel to the earth. So we can use the video filter to rotate it. So we're going to do ffmpeg-i traffic.mov, and then -vf for video filter, and we're going to specify rotate equals, and then I'm going to put -10 times pi/180, and then specify the output file, calling it traffic-rotate.mov. So the input unit for this filter is in radians. I'm better at specifying degrees, and so the way to do that is you can specify the degree and then multiply by pi and then dividing by 180 to get the units of radians. So let's go ahead and do ffplay, or the output, traffic-rotate.mov. So here you can see that now the horizon is parallel with the ground, right? So it looks a little more normal. But you do see the black bars surrounding the edges. And so if you want to get rid of those and just view the portions of interest, we can add the cropping filter to this. So what we can do is ffmpeg-i traffic.mov-vf, then double quote rotate equals -10 times pi divided by 180, comma, crop equals 640:480, end double quote, and then writing out to traffic-rotate-crop.mov. And when it's done, we can use ffplay of traffic-rotate-crop.mov to take a look. And here we can see that we're viewing a video that is a rotated and then cropped version of the original. If you have a media file and you are interested in extracting just the audio, you can specify to FFmpeg to only give you the audio. Let's take a look at our input file, ffprobe-hide_banner of kona.mov. We see that there is a video stream and an audio stream in this media file. We will use the -vn option, which stands for no video, and then the name of the audio output file. Once again, FFmpeg will do the codec conversion depending on the file extension of the output file. So if we do ffmpeg-i of kona.mov-vn and then kona.mp3, we can do an ffprobe on the result with the -hide_banner, and we can see that FFmpeg has converted the audio to an MP3 format. If you have a media file and you're interested in extracting only the video, you can specify to FFmpeg to only give you the video with a -an option, which stands for no audio. Then you can specify the -c:\v for copy video, and then the name of the video output file. Once again, FFmpeg will do the codec conversion depending on the file extension of the output file. So we're going to do ffmpeg-i kona.mov-an-c:\v copy kona-mos.mov. So once that's done, we can do ffprobe-hide_banner on kona-mos.mov. And as you can see here, the output file is just the input file, but without the audio stream. If you have a media file and you are interested in extracting still frame images, you can use the video filter to specify the output. So if I do ffmpeg-i of kona.mov-ss2-t3, we're basically going to search to the second into the video and then go for 3 seconds. And then specify the video filter with FPS equals 3. And finally, the kona-%3d.png as the output file format. And when we're done, if we do an ls, we can see that this generated 9 PNG files, right? Because 3 per second for 3 seconds would be 9. And they're named kona-001.png, kona-002.png, etc. which is the format that we specified. And let's go ahead and open the PNG file. I'm going to do xdg-open of kona-001.png. And you can see here, looking at the time frame, if we use the left and right arrow keys to step through each file, each picture, that's the 3 frames a second. There may be circumstances where you receive a ton of video files and need to stitch them into one long file. This is common in some home surveillance systems where the recorded videos are in 1-minute increments. So if the files are using the same codec, like they're from the same source, then the -f concat option can be used to accomplish this task. But first, we need to create a file list of all the files in question. So we can either do vi and create a list, or in this particular case, we're just going to do cat, redirect into filelist.txt. And I'm just going to type file, single quote, segment 1.mp4, end single quote. Next line is file, tick, segment 2.mp4, tick. Third line, file, tick, segment 3.mp4, tick. And then hit Control D to end the cat command. The other thing we can do is we can use the shell to help us do that. So we can use a for loop. So we can do for file in traffic dash $?.mov, semicolon, do echo file \tick $file \tick greater than traffic dash list.txt, semicolon, done. This will pick up every MOV file that matches the pattern specified and add those names into the file named traffic-list.txt. Once you have that file list, now we can read that into FFmpeg. So the command is ffmpeg-f concat-safe0-i filelist.txt-c copy complete video.mov. What we're doing here is that we want to tell FFmpeg we're concatenating a bunch of files, so that's why we have the -f concat. And then we want to read in the file list.txt, and then we want basically the codecs to copy into this new file complete video.mov instead of re-encoding. And here we can see that the video is going to be one long video composing of all the components. Alright, so that brings us to the end of this video where we took a look at the FFmpeg multimedia framework to handle audio and video files. This can be useful in audio-video forensics or just everyday conversions of files from one format to another. Hope you enjoyed it, and if so, click on the thumbs up icon to like this video. Please hit the subscribe button to get notified when the next video comes out. Also, please leave me messages in the comment section below so I know what you liked and didn't like, or what you may want to see in future videos. See you next time.